Okay, and it continues. Okay. Yeah, still don't know why this only printed with 6 significant digits, even though the answer actually had 9. Yeah. Okay. So standard character output doesn't output ending 0. Or, well, it just doesn't output it if it's 0. It's 5.000, nothing. It just says 5. It only gives value to things. So what about 6.7 or 6.70? I wonder. So if we do IO stream for output, and then we do float x, and we just list initialize at 6.70, standard character output, and we just print x, and then end the line without flushing. Or end flush the buffer. Wait, right? I think this is the one that this outputs it directly, so this flushes to reduce the delay. What? I'll do F. So it needs F for it to not default as double. Oops, I fucked up. So it does remove the last 0. Okay. Nope. Okay. Ranges. Four, 8, 10, 16 bytes. Oh, wow. Instead of 10. Why? Just because it's a 1.5 or a 2 multiplier? So it's even? Instead of 10, which would be a decimal. Well, 1.5 would too, so. Like 10 or 8 doesn't evenly go into 12, same as 10. Oof. Padded. Same range, really? Yeah, but there's like 30% more. Well, 50% more here. But it's also almost 50% more memory too. Same range. Holy shit. That's the biggest number I've ever seen in my life. It's an entire essay that's one number. Oh, okay. Yeah, I mean, if it was fully expanded, I mean, it would have thousands of digits. We can only have 30, 36 that are significant. It's crazy. Like out of that actual entire number, for something that big, the error is so large. Wow. In terms of what we can actually store on a computer just because it's so big. Just because there were so many fucking numbers. Okay. So, as regular float, regular double. Floating point precision. Decimal number is that. If you're writing it on a piece of paper, Yep. True. Yep. Sounds like this is the actual answer. Excuse me. Yep. Oh, wow. Meaning because the first 6 are accurate, but the rest, you could be off by a lot. We're talking about, I mean, it's not a humongous amount, but it's still a lot. If we're talking about 100 million, then you could be off by at most 999, which could be pretty important. Oh, wow. Hmm. Oh, wow. Oh, I didn't even see that. Oh, okay. IO stream input output stream for output. And again, it always thinks that, so we have to say it's a float. Hmm. Really? Oh, because it already only goes to 6. Okay. Hmm. Oh, oops. Really? I have to say point? Yeah, I guess so. Okay. Oh, excuse me. Okay, so it pads the exponent. Right now it's only 1. An output manipulator function. Hmm. So we're using a function to change whatever the hell standard output is. So in this case, we set the precision to be 17, which is 5, 5. Wait, what? Oh, okay. 5, 5, 5. Yeah, this one's definitely fucked up. Show 17 digits of precision? This isn't 17 though. This is 17. This is 17. Yep. Hmm. Oh, and that's because wasn't a double only up to 16? Oh, okay. Typically 16. Okay. So it could be more, but it's not. So in this case, we have a double and a float. Floats are only accurate to about 6, it looks like. 1, 2, 3, 4, 5, 6. In this case, it looks like it was accurate to 7. Oh, okay, that's why. So floats are typically 7. Doubles are typically 16. So even though we set the precision to be 17, oh, so the point here is to show 17 digits. So normally character output would only show 6. So it would look the same for these. We would only see these guys. So if we do set precision, okay. All right. Do I have to get that somewhere else? IO input output manipulator. Input output manipulator. And we'll do 10. The number is 1. That, and then we'll do the same as a double. So how big the number is accurate, but the precision's different. This guy was not running out. Let's do even more. Oh, because we're only showing 10. That's not the difference. Okay, so we'll do 25. So we got 8. 8 digits of precision with the float this time. 16 with the other. Okay. Or is that the decimal? No, it's significant digits, so sometimes it's more. Okay. So I can use this set precision to override how many floating point or how many significant digits character output, standard character output will output. Looks less precise, more error. Yep. They're sticky. If you set them, they remain set. Set W. Oh, okay. Not just fractional. There's a float. That's too many. It's showing 9. Seven, 8, 9. It's fucking up. So it's only accurate to here. Might have just been luck earlier. So we're using input-output manipulation in order to change what? How many significant digits it prints with? So it determines how many digits. We have this float has 10. We say show 9. We should get up through 9. But instead, we only get 7. A rounding error. Because it rounded this to be 9, and then somehow there was a 2 at the end. Hmm. Makes sense. My number is 10 digits, but I can only store 7 significant within the float. Well, my last 3 are probably going to be fucked up. Favor double over float unless space is premium. Lack of precision and float will often lead to inaccuracies. Yeah, it makes sense. Rounding errors make the comparisons tricky. I'll be right back. Nose is full of crap. Okay. Due to non-obvious differences between binary and decimal. Between binary and decimal numbers. Consider the fraction point. Oh, okay. A tenth. Yeah, I'm done with this fucking. Thing window I usually keep open. The glare. Okay. Oh, I fucked up. Yep. We're used to thinking of 0.1 as an easily representable number with one significant digit. Okay. The infinite sequence? 0001. 001, 001. What the fuck? Bro. Bro. The fuck is smudging on here? Oh my god. Okay. In binary, the decimal value 0.1 is represented by this infinite sequence? Fucking why? Because of this, when we assign 0.1. Why am I reading out loud, dude? I'm fucking stupid. Yeah, it sounds like when we have a floating point number that can only store some significant amount of, some set amount of memory and no more, some limited amount of memory, we can't store 0.1 because it's infinite, because who the fuck knows why? So it sounds like binary is not able to count for fractional numbers well. That's kind of retarded. Yeah, so we assign this 0.1 to a float, and then we print it, but then we print the set precision to see what it thinks the number is. Yeah, the first before we update the precision is actually more accurate. Hmm. Yep. Yeah, we're adding 10 of those. Each one's off by just that tiny little bit. Wow, we can't even add floats together properly. Well, yeah, I guess we can't. We're saying it's a double. We're saying each of those is a double. And we're adding all these binaries together. And then we get a binary value in the end. But it has all those little uncertainties that are adding up instead of just the one uncertainty. Hmm. Yeah. Damn. True. Yeah. Okay. Or, well, rounding errors occur when they can't be stored precisely. But we can store numbers precisely. We don't need that level of precision, so we should be able to. Well, when we're comparing them, I guess not. I was going to say if we're only printing them at the sixth digit. If standard character output only prints the numbers to the sixth significant digit, but the number itself that is stored, the value, is above or below that, or is outside that range. Yeah, even if we have a big number and we're only really caring about this bit, if we keep adding a bunch of these, eventually those errors could creep all the way up into the bits that we see. Okay. Or what? Oh my. Cool. Inf is infinity. It is signed, yep, not a number. Excuse me, signed 0. Excuse me. Yep. Double 0. Oh, okay, I see. So if we divide oh, okay. Wait. Okay, not 0 though. Okay, so we have infinity, not a number, and sign 0. So we can say 0 divided by 0 is not a number. 0 divided by positive infinity. Okay. What? What is it called? Oh, whoops. What the fuck am I doing? Do I have to include it? So do I have to limit where I use positive infinity to inside a double? Yeah, no. Yeah, fake news, buddy. Oh, wait. It's just the output. Never mind. So they actually do define positive infinity and negative infinity here. I see. Okay. And then what? Negative? Same? Yeah. Okay. IO stream for output. Oh, okay. Oh. Oh, wow. So you can't do that here. What that? Indeterminate? I don't know. Okay. Those aren't relevant right now, but noted. See. Hmm. Okay. Platform specific. Don't divide by 0. Okay. A little bit of music. Kids outside are being loud. Gotcha. Makes sense. Hmm. Oh, okay. So bool alpha is basically the same as set precision. Standard set precision, standard bool alpha. Okay. Oh yeah, I forgot I haven't even been doing this yet. Earlier in I was playing Osu. I was trying it with the keyboard really close to me, and it's actually probably going to be pretty cool for coding, so I don't have to lean forward. So for games, when I'm locked in, I don't like playing games back here because I'm just less consistent. I'm in a movable position, but when I get really locked into a static position, my elbows are naturally on the table, so everything needs to be forward. But here, it's different. Okay. So we want. Okay. 0 and 1. But then we can do. Well, alpha will change how character output outputs this stuff. Okay. Now we can do. What? What? Oh. Wasn't it? It's not raining. Oh, and that was... That's why I could do that, I see. Okay, so we're basically we're updating standard C out. What if we did... Oh, okay. So it does work like that. Cool. So we can modify standard character output. We actually want IO input output manipulation, so we can adjust the precision. We just want cool. So I could do that. I could do include IO stream for input. We want oh oops. Input output manipulation. Bro. Oh, it's okay. Excuse me. So we have a float. But we're printing it out to 15. This value in binary is represented larger than this value. It doesn't just terminate, which means we end up getting rounding errors after the maximum precision of a float, which is 6 significant digits, which in this case is here, or 7. Cool. Alright. If we want standard character output to print true or false, we use standard character output bool alpha. We change how it outputs it. The way. Just like a color, we choose how the color is expressed based on its alpha, its opacity. Okay. Want to know, but then we use bool alpha, true and false. No bool alpha to turn it off. Okay. Okay, so we do include input output. We'll just do the different outputs. All right, we'll do yeah. Okay. Or we'll do I'll make a file called print stuff. It's going to include IOStream for input and output. It's going to be called print stuff. It's going to take an input, which is a boolean. We'll just call it input. And then we'll call him. He's also going to include print stuff.h. This guy does not need input output. And he's going to we'll do, as I want to manipulate here and then do some more stuff and then remove it. What if I do, dang, doesn't work. That works. Okay. Alright. No, motherfucker. Okay, what do we want to do? We want to output input. That's it. And then we'll make a header file for it. That's cool. Okay. So we'll do print stuff. And we will print zero, print true. Cool. True, and then we'll print false. And then we'll do the same thing again. And then we'll That's cool. And the issue here would be the bool alpha. Yep. And if I did this, we do that. Cool. Oh wait, oops. Where did it go? I don't know where it went. Cool. Okay, so we can do bool alpha and no bool alpha. Uniform initialization. Ain't nobody told me we're doing the B shit yet, bro. Uniform initialization? That's just list initialization, or rather direct list initialization. Okay. Use false and true just so we know. Well, yeah, because we're doing a narrowing. Well, is it a narrowing conversion? We're going from an integer. Well, yeah, it is. Because we're going from an integer to a boolean. A boolean can't fit the value of that integer, so we are narrowing the conversion. It would have to go down to 1 or maybe 0. Same thing as if we were taking 1.0 as a float or a double and then converting it to an integer. Well, is it just point or is it 0.0? Regardless, we're losing some sort of precision there, maybe. So it refuses to let you. At least with warning errors, warnings treated as errors. 0 is converted to a false. True. Okay. Oh, the point is because we're. Oh, duh. Because we're doing during direct list initialization, it prevents narrowing conversions. But if we assign it the value, no sir, using copy initialization. Yep. See, I wasn't even reading that. Copy initialization allows implicit conversion. Same. Well, it wouldn't have cared in this case, because so would direct list initialization, you retard. Yep. Because there's no narrowing conversion here. Well, so does this, it's just that it's a narrowing conversion with this value. This would be, so this is a good example, but this is not. Because this would have been allowed anyways. Yep. Let's try. We do... No, sir, it's narrowing conversion. What if we do instead? Ooh, truncation. It's because it's conversion, but it's not a narrowing conversion. Well, it is. It's just that it's allowed, and it's called truncation when you can actually do it. Truncation sounds like just that's a conversion. Inputting Boolean values trips new programmers up. So we default them to false. Enter a Boolean value. Oh, okay. Character inputs only. True and false. Gotcha. Failure mode. Yeah, that's what I was gonna say. Because we did that in get string, get int, but that was all predefined shit made for me already in C. I think, yeah. Yeah, so it failed, but it failed by just having a wrong error. Or rather, it failed by having a, just an incorrect value initialized. It sounds like there's probably some sort of conditions in there that say, hey, is the input this, do this. Is the input this, do this. Is the input this, do this. It's a Boolean value we're assigning to. 0, false. True. Or, sorry. 1, 1, 0, 0, etc. Hmm. Oh. Let's try a couple of these then. So we'll do input output. We'll do extract to here. Or first we're gonna do, or we'll do, how did I zoom in and out? Oh, it's terrible. Oh, well, I could fully lock in. And then we could do instead. So we'll do. Oops. Okay. See what the errors are. It's going to be 2 or 3 no identifiers and then can't open source file. So, boom, 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 boom. Cool. Okay, we'll do a CPP file. Whoops, meant to rename him. I'll call him get and print value. He's going to include get and print value. He's also going to include iostream for output. It's going to be called, it's going to be a void. He's not going to input anything, nor is he going to output anything. What he's going to do is he's going to have a variable, just a local variable. Just call him X, it's fine. We'll call him value. And then we'll just store the value and then we will print the value. And then we'll have a header file. Oh nice, I can just print this tab. Oh, that's cool. Nice. Call him get and print value. Yep, .h. We'll do if not defined get and print value h. Define get and print value h. And if. What are we ending? Or what are we actually doing? We are. Oh, ice machine. Okay. We are for declaring get and print value. Everything works. So first, going to print a numerical or print an entered numerical print. Print a numerically entered. Alright, I'm done with this. Boolean. And then print a word entered Boolean. Okay. So we put in 1. Oh wait. Oops. Forgot it outputs it, but then it doesn't. There we go. Didn't go down the line. So we'll put in true. Wait, what? Yo? Oh. Is it so one? One? So we do 1, and it outputs that, and I do false, it outputs that, and then I do 1 again, we do that. But if I instead do false, it fails and outputs everything. If I do 1, but then I do 1 again, it fails and outputs everything. And then if I do 1, false, and then 1, then it's fine. Okay. So the point is that bool alpha switches what character input is expecting. And it doesn't just allow it to accept the words, it actually swaps it to only accept the words and fail otherwise. Interesting. Okay. To allow it, we must first input so first we extract. Sounds like we're just changing him, but it does mean that we're inputting to bool alpha. So it okay, so here's how it works. So we either have character output or standard character output and standard character input. When calling standard character output, it checks, what am I inserting values to? Or what type of values am I inserting? Oh, it's an integer. Okay, let's get that, okay, it's an integer. Alright, we'll put the integer in there. But if it's instead standard bool alpha, or sorry, but if it's instead set precision, then it will not give itself a value. It will instead change some sort of, well, I guess it will. I guess inside standard character output there's a condition. And if it's a regular ass value, it does this, it prints it, it outputs it to the console. But if it's instead set precision, it doesn't output it, and it updates something in there so that its output is changed for future output. For character input, it checks, okay, where am I outputting stuff to? Oh, I'm outputting stuff to bool alpha. So what that means is I'm going to change what I'm doing in the future to output something a different way. Or to store something a different way. So there's changing what we're outputting, and then there's changing what we're allowed to input. By default, the success behavior is if it except for a boolean is 0 or 1. But if we instead extract to bool alpha, it says, hey, I don't actually need a value. Don't prompt the user for one. Change what we're allowed to accept. Just like for standard character output, it changes what we're allowed to print. Usually it prints 6 digits for a float maximum. But now it prints whatever number you want. Now, usually character input for a boolean only accepts 0 and 1. But now it's true and false. Changed what it does. It doesn't do 6 and 17 values outputted. Character input doesn't accept true and 1. It's or. You output 6 or 17 characters. We accept true or 1. Okay. I got piss. But this music's kind of good. Sure, it's still annoying. Took a one Motrin. Usually try not to take meds when I can, just so I can let my body get stronger or whatever. But in this case, it's annoying, and I'm talking because I'm recording, so I can understand better. Yep, 0 and 1, and case sensitive won't work either. We prompt the user. We didn't say yo, true or false. And then we extract it. And we output true or false. Yep. Numeric values will not be accepted. Excuse me. So not only is it true or false, not only does bool alpha switch character input and character input, and character output from characters to numbers or numbers to characters, it's also case sensitive, so it won't output capital T or capital F, but it also doesn't allow you to input capital T or capital F. Oh. Oh. Hmm. Okay. So functions can have Boolean return values. Oh yeah, I forgot I could do it just like Osu earlier too. Raise these guys up. Convenient programming now, baby. So we'll do oops. Wait, oops. So we'll do so we need to return a number. Point is we're going to run a function to get a number, run a function to get a number, run a function to, and then just print whether those are equal. So we'll print is equal. Print some text saying is this equal to equal, whatever? Is this equal to that? Is A equal to B? And then the answer. So we're just returning the value. So we'll do so all we're doing here. Oh yes, you're not including that yet. Oh wait, well this is actually fine. This is the header file, duh. Oh. Okay. Oh wait, oops. Forget they don't have to be the same name. There's a link issue because main wasn't a thing yet. We'll also have that's it for now. Oh, we'll also do yeah, we'll do that too, it's fine. Um. Yeah. Print. Result. Print equivalency. And we'll do alright, we don't need this. It's easy enough. We'll just do oh cool. Okay. So return. Oh well, I guess we'll just do so he's taught how to do that now. Okay. Hmm. Okay. Really? So this is an operator. This is equivalency operator? Equivalency operator returns whether the value on the left equals the value on the right. Okay. Hmm. Oh, I can feel. I think there's a pimple of Garn in there, dude. Just because I've been wearing earbuds too much. Need to just listen to shit out loud more. Okay. Okay. What about? Oh, I was gonna say, what if I enabled it to do the other way? So I extract. Well, no, that wouldn't even make sense. Never mind. Okay. It was all that just so I don't have to do this. Alright, I guess you could do this where you have a space just so this continues. I'd rather just put this here. I mean, it only adds this much. It's literally all it adds. It would have just gone to here. And you already have a comment that's going longer than that, so I don't see the benefit in doing this. I mean, I guess it makes a statement more complex, but not really. All it would be is output, are this and that equal? Result. Instead of are this and that equal? Result. Like, yeah, I don't know. Okay. Here we go. I have to breathe through my nose to get a full deep breath. That's annoying. Getting fat, 150 pounds, 5'8". Damn. Can't even breathe properly anymore. Well, damn. So it's evaluated. Yep. 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 Holy shit, really? Let's go, dude. Okay. Excuse me. Cool. What the fuck? Bro, that second one is stupid. Get a value. Save a variable to if that is 0. If the value is 0. And then have an if statement that is saying if the value is true, then that, and if the value is not true, or if yeah, if the value and if not the value. What the fuck? Alternative form called if else. I need a fucking soda. Throat is whack right now. Fuck. I'm getting water. If else, so you say if something, then something. If true, it does that. If false, it does that. Okay, so we'll do we need some output. We need and then we'll do cool. Oh, that's why. Okay. All right. Okay. Oh, so the point here is this. These guys are different. Else if is not one thing. There's an else, and then there's an if. So this reads like this. If this. If this, do this. This could be on the same line. Else, next line, if this, do this. So if this, do this. If not, then if this, do this. Else, this. So these two guys are within else. If A, do A. If not A, if one, do one. Otherwise, do this. greater than and less than operators. They both return booleans. Okay. Okay, we need input. We need. We'll just do int x this time. Oops. Oh, that's so much better. Forgot that my freaking armrests could be better. Cool. Okay. So this is the same structure as this. If this is true, do this. If it isn't true, do this. If this is true, do this. If it's not true, do this. So this is a nested if statement. This is a nested if else within the else of an if else. Here's A, here's B. There's A, there's B, and then C is within C is, or then there's B1. Okay. Usually we just do else if. Like that. How does that look? Is that better? So we'll do want use the value. Return value sign or F0. Okay, so we have positive, negative, 0. Okay. Okay. So we got two values, true or false. And then output it if they were equal. Okay. Yeah, I'll do that better. Need output. We need a value. And then we need we'll just do well, no, we wouldn't do that. Oh, yeah, we would. Oh, oops. Well, cool. Yeah, so this turns into 8 lines when it could be shorter. But well, it'd be 6, so it's not that much shorter. Okay. It's better now because before this was redundant. Well, this was repetitive. And then we said x and y are equal, yes or no, true or false. We had a function to check, and then we printed the value of that function. Or do this for that, do this for that. 2 unique cool responses instead of one that has detailer to both ends. Hmm. Oh, you're saying in this case our conditionals, being if this, if that, are either true or false. What happens if the value ends up not being that? So if true or false. What about if 4 or if 0 or if -1? Excuse me. 0 is false. Everything else is true. Saying if something, what is the something? Something's 4. 4 is true. Okay. Hold on. That's almost done. Oh, we can have a return statement in a void function, non-value returning function. Just not returning something, just return. The return basically means return with, that's return with nothing. Return 4 is return with 4. Or rather, return nothing, return 4. Void print. We will never print B. It's because we're returning right after. Yep. Hmm. Turns about absolute value of x. Abs 4. Is 4 less than 0? Return negative x. Otherwise. Oh, okay. Some output. We need some absolute value stuff. So we'll do. Okay. So we'll do. Okay. So the point here, we're getting a value from the user. What do we want to do with it? We want to. We'll return from this. We'll just call this okay, so we're saying get a user value. Return absolute value. We want to use a value, so we'll prompt the user. Value initialize the value. Store the value, extract the value from input. And we'll output it. Absolute value of whatever the person input is. Call this function. Is it positive? Well, it's already the absolute value. Is it not? Return negative x. Or we could just say, is it negative? Because that didn't capture 0. This would be the easiest way. Or we could do greater than or equal to 0, or do x. Else do the otherwise. But we'll do if it's less than 0. That way this captures if it's greater than or equal to. So we'll do 3. We'll do negative that. Okay. This time we'll do double. And we'll do double. Double. Cool. And then we could do input output manipulation. And we could do change our output to be long. Cool. Okay. Wonder why. The only way, I mean, because if you didn't return early here, you could just do int x, set x to be this, if this, else, set x to be x, and then return x at the end. But then every time you have to go through all the shit instead of just, if something, then something. Like, I look at my wallet, do I have enough money? Buy shit. Good. If I check my wallet, if money is less than 10 bucks, leave. Don't care about anything. I don't want to go and look through the rest of the store. If money is less than 0, set money to 0, or set gonna leave store to true. And then other shit like, because if this happens, and this happens, and then there's an else if, and then we just ignore that, and then return at the end, I'm just executing more fucking code instead of going here. I'm not even checking the else if. Instead of checking it and then returning the shit at the end, I just return now, don't check anything. Boom. The debate over early return functions later. Continue? Never heard of that. Okay, what is an early return? An early return returns to where the function was called in the caller. Returns to the caller where the callee was called, with a value if provided one. It ends the function early. Statement A, statement B, return after statement A, function runs, statement A, and then returns. But we could have conditions instead that check if A, then do this, return, if B, then do that instead of returning. Yeah, it's before the end return. I'll check this first. How can the length of the following code be reduced without changing the formatting? Say if, are we allowed to take a ride? Output, have fun. If not, it's too short. So we say, is a boolean. We ask how tall. We have a double. We give it height. Wait, this is redundant. We're asking, this returns a bool, and then we check the bool instead of just returning the check result. So we're calling a function to determine a bool, A or B, and then we are checking if A or B do this. So we're saying we're dropping a ball down a hole, and it goes through either one of two, track A or track B. And then we check where it goes at the end. Oh, it came out of A. Now do this. Instead of just, and then rolling it down the hill. It should just be drop the ball down A or B, and then it goes and does what B needs to be doing or what A needs to be doing. So this should just be main. And we change this to be void is allowed to take fun ride. And then in is allowed to take fun ride, void. It doesn't grab anything. It just asks how tall. It gets the input. If tall enough, return have fun. Else, return too short. So we have reduced the code by, right? So we would say, still need this line to check. And then we don't really need an early return. Well, I mean, I guess. No, we don't even need an early return. We don't give a fuck. Remove these. If this, print that. If this, print that. We don't need the else. We don't need this. We don't need this. A prime number. Write a program that asks the user to enter a number. If the user enters a number, print prime. Otherwise, print not prime. Don't have access to modulus. Could do a loop to get the answer and then divide it by all. I'll make a function that works first. Speed this shit up. Find the answer and then make the answer better. Or find a solution that make the solution better. Ask the user. Okay. 1 to 9? 0 through 9. Extract the answer to value, and then okay. Give him a number. Do this, but This is the redundant part though, maybe. Like, I mean, I could make this better, but I don't really want to. We don't need to return each time, that's fine. Oh, I've been doing this wrong. I mean, so here's one terrible way. Get this from the user. Run and we check. If this, then it doesn't run this shit. If this, it doesn't run the rest. Okay. It's a better way. I mean, we could do loops. Ugh. I don't know loops yet, technically. Get the value, check if it's prime. So what do we want to do? We want to say, is it 2, 3, 5, or 7? I mean, I could make this one statement. But we don't have the OR operator yet. Because this is my weakest spot, figuring out my next option. So what do we want? If it's prime, print the digits prime. Yeah, I mean, sounds like it's the only way. Yeah, I guess that probably makes more sense, huh? Excuse me. I just put a fucking semicolon. Ugh. Check with the prime values. Okay. Yeah, that made more sense. I could have made it better from the beginning. Should have known redundant shit. Check for the value. Do this if that, do this if that. Not different thing for different value. Oh shit. Oh. Wait, really? So does it return false otherwise? Because I would have said if this is this, return true, else return false. But this is returning X. isn't it? If x is 0, so it returns x if maybe if it doesn't have a return value, it returns false. And returns true if it gets a specific value. A switch statement. Switch x. Cases? So there's switch x, and we put in the different variables for we put in the different values it could be, and any of those would be returning true, or they could have their own different behavior, and then return. Holy shit, that's fantastic. Alright, let's see. We definitely need output. The point of this is, if this was only true, if this is true or false, if it was true, just do the true shit. If it's false, just do the false shit. Because there are multiple answers, multiple specific answers we're checking for, then we need to get the value and then check what it was. But here, we're only checking one thing, height. So instead of returning true and then checking true and then saying this, or returning false and then checking, we just move have fun to here, too short to here. That shaves 3 lines of code. Anything else? And then we just call this as a statement. And this is now a void. It doesn't return anything. Then we say height, extract input to height. Return, oh shit. You never need an if statement of if this, true, else, false. You can just do if condition. No, you could just do in a function, return the condition. Oh shit. That's why that would work. We return true or true or true or, well, it would be return. Oh, we're basically just doing the comparison. So return true or false. It's checking all, and then I guess it's checking all of them to see if any of them are true, and then it's false. Or no. Yeah, because if any of them are true, then it's prime. So this could be false, false, false. It's 7. True. returns. So it checks all of these. So it returns true if it's any of these, and it returns false if it's none of them. So it checks that's false, that's false, that's false, that's true, returns true. Or that's false, that's false, that's false, that's false, false. Wow. I've never used it like that before. So here we can say if is allowed, do this. If not allowed, do this. We might want different logic, so maybe we don't want to put this in the function. We want this to just check. And I guess I was changing the formatting. We check, we say, how tall are you? We put a number, and then we just say return height is greater than or equal to 140. We evaluate this expression. His height is 180. Return true. Height is 139.9. False. Wow. Really? So we'll do really? That's crazy. Prompt the user. Want user value. Want to check value. Compare 10 is special comparison value. We do 22. 2. Wow. That is so much more concise, man. It's 75% better. Instead of it being if value is greater than 10, return true, else return false. That's crazy. Literally trimming off 3 out of 4 lines. Holy cow, that's amazing. That's actually cool. That's probably the main, like the first real cool thing I've had in programming before. Characters, huh? See how long I've been going? Okay, I've done 4 hours and 40 minutes of coding today. This is way better. I'm just gonna do them all in one block and then just upload them straight up. So like, I get off work, get on the computer, click fucking record. I have zero urge to stop, especially since I can sit here like this. I turned up the tightness to my chair, so I'm not leaning so far back now, falling asleep. I'm not tired at all. And I'm just sitting here, legs crossed, just fucking keyboard within reach. And then when I need to fucking lock it in, pop the armrest down, pop the armrest in, keyboard away, mouse. We're fucking ready, son. And then back, up, and we're good. Nice. And then the keyboard can be there too. It's cool. What if it hears this? Probably. Let's see. Oh yeah, it can. Alright. Damn, this chair is the best investment I've ever had. Like, besides a PC, this is probably the second best thing. I can't believe it. Wow. Because the bottom isn't going to evaporate over time like that piece of shit. And then I can still just sit and lock in. And wow. Wow, why did I even take them off before? Oh, I think it was because the armrests hit the table, so I took them off. But here, I can just raise them and lower, so I'm good. Alright, here we go. Characters. Looked at integers and floats and booleans. Would you like a burrito? Yes or no? Oh. How do we do that? Single character. Character could be single letter, number, symbol, or white space. Character data type is an integral type. Integral type. Integral type. Underlying value is stored as an integer. Similar to how a boolean variable is interpreted as false and non-zero as true, characters are interpreted as ASCII characters. Oh, there we go. I was wondering why the chair was less comfortable for a sec. Stands for American Standard Code for Information Interchange. Excuse me. What is 65? Capital A? Yeah. Character literals are single quotes. Hmm. It's a bunch of shit. The unprintable characters. The printable characters. Space. Is there inline? This inline isn't ASCII. It's something else. Okay. Initialize them using character literals, just like 0.0f. We do, or yeah, like text for character output being quotes. In this case, we do the apostrophes. You can do with integers, but avoided, or the character literals. Stored the same, but more transparent on the coding side. Do not mix up character numbers with integer numbers. These are not the same. Initialize with integer 5. Stored as integer 5. Initialize with code point for 5 as text. That answers some problems I used to have. Had some kind of thing that checked letters that a person would enter. And I was wondering why they would sometimes end up as numbers that were like the correct number, but it was because the numbers are also, so these are the text numbers. So 57, so we just subtract, oh wait, I remember that, having to subtract, or like add 47 or something like that. Add 48 looks like. I feel like 48 is familiar, but I don't know if that's real or not. And then what's the one? 65 to 97? 32? So if you store that, it's going to store 53. If you do that, it's going to store 5. Okay. If we use standard character output, it outputs the character variable as an ASCII character. So if we do either of them, it does it. So outputting a character outputs it as a character. Okay. All right, that's it for now. About to be D&D time, so we'll go back to this later. Okay. All right, think I'm good to go. Let's do it. Later. I guess that's it. Not really doing anything now. What am I saying?